In this video we're going to look at another couple of examples to do with vectors, application of vectors. Now I'm just going to read you a scenario which hopefully makes sense. I'm going to fly from town A to town B, which is due south. It's 2,000 kilometres away, and we know that there is a breeze coming from the northwest, right, that's blowing at 150 kilometres per hour. Now if the plane flies directly to town B, what's going to happen is the actual plane will end up over here somewhere, right? And that's not really going to be useful. So what pilots need to do is they need to allow for the different wind conditions and set a bearing so that they can actually aim for a point maybe over here somewhere, and then they'll end up at B. Now the thing that you have to do for this scenario here is we know that planes can travel at about 1,000 kilometres per hour. Alright, so let's say it's going to take 2 hours. We're going to plan our trip for 2 hours. If we're planning our trip for 2 hours, the effect of the wind over the 2 hour period will push the plane this way 300 kilometres. Does that make sense? Right. So what we need to do is we will need to, if we're flying this plane, we'll need to aim at that position there. So we'll need to set a course where we're going to aim the plane at, knowing that the breeze will push the plane towards B and we'll get close to the airport. Right, we know it's 2,000 kilometres there. We know the plane has an ability to fly at 1,000 kilometres an hour. Probably won't have to go quite as fast in order to reach there. Now the key thing is we need to know some angles here. Now we know this angle here is in fact equal to 45 degrees. It's coming from the northwest. We know the angle there is 45 degrees. So again, the same process as what we did before. We want to find this distance D. We use Python for doing that. Not Python, we're going to use the cosine rule. So that's simply going to be 2,000 squared plus 300 squared, take 2 times by 2,000 times 300 cosine of 45. Alright, so that will allow me to work out my D value. So let's go to calculator. Alright, now probably important to put a bracket there. So 2,000 squared plus 300 squared. Take 2 times by 2,000 times 300 times cosine of 45. Right, so then that will give me an answer of, oh, there's maybe a bit of an error there. Just delete that last bracket. Right, something wrong now. It hasn't worked out in the brackets right. So let's do that again. Make sure your calculator, you have to understand whether your calculator is giving you the right answer. So you've got to put it in there correctly. I'll use my brackets. 2,000 squared plus 300 squared. Take 2 times 300 times cosine of 45. Bracket, enter. That sounds like a more realistic answer. So it's about 1,800. 18.4. So over here, so D is equal to 1,800.4 kilometres. That's how far I really need to travel. So what speed would the plane need to fly at? So rather than flying along at 1,000, I could go at 900.2 kilometres per hour. Good enough. So that would save a bit of fuel, and I'd still get there in the 2 hour mark. Obviously if I flew at 1,000 kilometres, I'd get there a bit earlier, but I'd have to allow not quite as far in that direction to be affected by the breeze. Now that's the one thing that I need to do. Now the other thing I need to work out is the bearing that I need to fly at to set my instrumentation in the plane to go there. So I need to know that angle there. And again, it's the same process of what we did in our first example. we need to identify using the sine rule. So sine of theta, corresponding side is 300. The angle I do know is 45, so sine of 45, corresponding side is 1800.4. And so therefore theta is equal to the inverse sine. The 300 goes to the top line, sine of 45, all over 18.4. And so therefore to the calculator we go. And again we can do that in one step, inverse sine. Alright, so 300 sine of 45, divide that by 18, go back 1.4, and then that actually works out our answer to be 6.7 degrees, 6.8 degrees. So theta is equal to 6.8 degrees. So therefore, if we're thinking about what our bearing's going to be, it's 180 going straight down. So therefore, the plane needs to fly at 900.2 kilometres per hour at 186.8 degrees true for 2 hours. So if we fly for 2 hours in that bearing, we're going to end up in town B, right, which is what we want to do. Right, so that's our first example. The sort of second example you might see is you have Sally who's riding a horse, that's 50 kilometres per hour, and Freddie who's riding a bike at 30 kilometres per hour at those different bearings. And if they go for 2 hours, how far apart are they going to be after the 2 hours? Right? Again, we always think about, when we're doing our bearings, we always think of our north line being an arrow like that. So we know this bearing here is 70. We know that there is 130. So that makes this angle between the two of them 60 degrees. We're trying to find this distance here. That's what we're trying to find there. And again, if we're going for 2 hours, we know this is going to be 100 kilometres. This one's going to be 60 kilometres. So therefore D is going to be the square root of 100 squared plus 60 squared. Take 2 times 100 times 60 times by cosine of 60, and we can work out that distance. Alright, so I'll just quickly have the calculator to do that. So square root, so it's going to be 100 squared plus 60 squared, take 2 times by 100 times 60 times cosine of 60, and enter. That gives us 87.2 kilometres apart. So D is equal to 87.2 kilometres apart they'll be. The other thing I might want to know is what bearing would Sally need to travel at in order to, what bearing would Fred need to travel at in order to get to Sally? That's what I need to know, wouldn't I? Okay, if I work out this angle here, again I'm using corresponding side, so sine of theta, corresponding side over there is 100 kilometres, is equal to sine of 60, corresponding side is 87.2, so theta becomes equal to inverse sine. This is about how quick you need to be able to do these questions, because they're just doing a repetitive sort of process. Alright, so down to the calculator, we'll work out that angle, so it's inverse sine of 100, sine of 60, divide that by 87.2, and that will give me an answer of 83.3 degrees. So theta equals 83.3 degrees. Now that's not my answer in terms of my bearing that I need to travel at. I need to do a little bit of thinking about that. So in this particular case scenario, that's the direction they're going there. Now I know, so I need to go in that direction there. So that's 87 from that line there to that line there. Now we know this whole line's going to have how many degrees in it? That's going to have 180 degrees. So that's going to be, this angle here is going to be 100 and, or not 100, it's actually going to be 96.7. 96.7. If I continue that as a straight line. We know that this here would be 180 degrees, that's around 60 degrees. Now what I'm trying to do is I'm trying to think about this particular bearing from, because that's what I want to do, is I want to work out the bearing from north. So, and sometimes you get to a point where you go, I'm not quite sure how to draw this. So sometimes it's better just to draw this section again and put some clear lines on it. So we know that this angle around here going from there is 130 degrees. We're drawing our north line there. Alright, and then this is our line possibly going to Sally. So we know that this angle here is going to be what? It's going to be 83.3 degrees. If I did from my north line there, that would mean that this angle would be, because we know it's 180 degrees in a, so this actual angle here from the north line would be 130, wouldn't it? So therefore this angle here has got to be 50 degrees, which means 50 degrees is used to get to that point there. That means that this angle in here is 33.3 degrees. So that's the bearing that I need to travel at in order to get to Sally if I was Fred. Get the idea? So you've got to do some little, you've got to do a little bit of planning and working around with angles, right? So to get all of your marks, you'll need to actually work out that angle. So therefore, bearing to Sally is 33.3 degrees true. And that's what Fred will need to travel at in order to reach Sally after the 2 hour mark. Anyway, I hope these sort of make sense to you. Once you get the hang of them, they're not that hard and they're quite interesting, I believe, these sort of questions, because obviously if you're doing any orienteering or anything like that, if you're working as a pilot, if you're doing any yachting, you'll need to plan out trips to do with current and wind and so on. So these are all very, very useful skills, and certainly vectors is something that is used in real life.